Hello everyone. So let's start the next topic related to perpetual series. Now what do we mean by perpetual series and how it is different from annuity series? In case of annuity series, it was a limited series. That is, there was an end point T1 to T4 and or maybe some other annuity series. But when I say a perpetual series, it means series is going to extend till infinite. Now what are the types of perpetual series which we are going to discuss? The first series is called as perpetual constant cash flow model. In this case, the cash flow which is arising, first of all, it will be a multiple cash flow series. So cash flows which will be arising will extend till what point of time? Infinite. And the cash flows will be always, that is your CF1 will be equals to CF2 will be equals to CFnth will be equals to CF infinite. All cash flows, whatever is the point of time at which they are placed, the cash flows will be equal. The second type of cash series is, which we are going to discuss, and it is part of our Gordon growth model when the valuation of equity share we are going to discuss. So it is perpetual constant growth cash flow model or series, where growth rate is constant. Here I am assuming a rate of 6%. This 6% is assumed. There can be different growth rates also. What will be the characteristics of this series? What are the characteristics of this series? First of all, it will extend till infinite. Next, the cash flows will grow. Every consecutive cash flow will grow with a constant rate. That means your CF2 is equals to CF1, the first cash flow, plus growth for one period. Your CF3 will be equals to CF2, 1 plus your growth rate for one period. We can generalize it to be CFnth plus 1 should be equals to CFnth 1 plus G. So in this series, every next cash flow will increase with a constant growth rate. So here I am starting my series with 100 and a growth rate of 6%. 6% is assumed. Of course, there are models to arrive at this growth rate for companies also, which we will discuss in the valuation of equity. So 100, starting with 100, it grows by 6%, becomes 106 at T2. Then again 6% on 106, it becomes 112.36, then 119.10 and so on, and it will extend till infinite. And this is called as perpetual constant growth cash flow model or Gordon growth model. Next type of series is perpetual unequal cash flow series, where the cash flow, there is no pattern in the cash flow and the cash flows are extending till infinite. In this particular type of problem, we cannot do any calculation because we do not know what will be the next cash flow. At least in the first two series, there is a pattern and we can say at what point of time what will be the cash flow. We can calculate. Even at T50 we can calculate by, in first series it will be always 100. In second series we will apply 6% growth and we can arrive at cash flow standing at T50. So can we calculate future value of these series? Of course, in this particular case also the future value will be infinite. In future value for all these type of series will be always infinite. But can we calculate present value for third series? Of course no, because we do not know what are the cash flows standing at different point of time beyond T4. But in first two series, yes, we can calculate the present values, and then we will apply this model in valuation also. And this Gordon growth model is actually used for valuation of equity share also. And the first model is used for valuation of perpetual bond and perpetual preference shares valuation. So can we calculate present value? Let's stick to the mathematics part first. Present value, it means we are going to discount. So first start with the present value of perpetual constant cash flow model. Present value means bringing backward. Backward means at T0. What is the relative equivalent value at T0? The series is extending till infinite. 100 will be coming for infinite time. So in nominal term, it becomes 100 into infinite is again infinite. But what is the present value? Relative present value at T0 for all the 100 extending till infinite. So the infinite present value should be infinite. No, it's not like that. Let's do the calculation part. So 100 standing at T1 going backward. So 1.10 will be in the denominator. Let's say the rate of interest is 10%. So 1.10 will come in the denominator. We will go backward, one backward from T1 to T0. So power will be 1. Then power 2 for T2. 100 for power T3 100, it will be power 3 and so on till infinite. We will take 100 common from numerator. So what is left in the bracket? 100 common, 1 upon 1.10 power 1, but then 1.10 power 2, then 1.10 power 3 in the denominator, and so on. And all these fractions are in addition form. They are going to be added in this bracket. So can we calculate this sum of this particular bracket? Can we calculate the sum of this bracket, the values which are extending till infinite in the bracket? Yes. In arithmetic, we have solution. Again, this is a GP, geometric progression, and extending till infinite, so it is a infinite GP, and there is a formula for sum of infinite GP. There is a formula for sum of infinite GP. The sum of infinite GP is A upon 1 minus R. This formula, let's not derive this formula. There is a derivation for this formula, but let's use this formula. This is from arithmetic. So sum of infinite GP is A upon R. Now what is A and what is R? A is your first term. R is your rate of change of GP. That is at what rate the next number is growing. Geometric progression. The number should be multiplied. At what rate it is growing. So A is 1 upon 1.10. The first term in the bracket is your 1 upon 1.10. What is the rate of growth? That is how much, by what time second number grown from first number. By what time third number grown from the second number. So divide it. The second number will be divided by the first number. It will give you the rate of change. Rate of change. That is rate of change is second number divided by first number. So we got 1 upon 1.10 power square, because second number is power square in the denominator, upon 1.10. So square got cancelled. We got again 1.10. Putting these value of A and R, and we got the final sum of this bracket as 1 upon 0.10 only. So let's put this value in the bracket. We got what we are going to get. We got 100, same value, and the complete bracket become 1 upon 0.10. So the value is 1000. Looks very, means it's a surprising that the 100 which are extending till infinite, the relative value is only equals to 100, only equals to 1000. How? Why? The reason being, as you move forward, as these hundreds are moved forward in the time, the first 100 which is standing at year 1, 2, 3, 4 and 5, the first 100 which is standing at T1, what is the relative value today? Discounted for 1 year. So present value is equals to 100 divided by 1.10, it gives you 90.90. The second 100 which is standing at T2, you have to discount, you have to bring 2 step back, power 2, it is 82.6. The third 100, you will do 100 divided by 1.10 power cube, the value is 75.10 and so on, 68 point something and 62 point something, and gradually it is decreasing. The relative worth, the 100 rupees which you are going to receive after 3 years, that is T3, today's relative value is only equals to 75 rupees. So as this 100 is moving forward in the time, its relative value is decreasing, and ultimately the relative value became negligible, 0.00 something. So when you of course it's not going to become 0, there will be certain value in decimals, but when you are going to add up all those values, relative values, it will become 1000 only. This is what this calculation is saying. So from this we can arrive at a model. The model says present value at 0, is equals to your 100, that is your first cash flow, CF1, divide by 1, not 1 plus I, it's only I. But this model cannot be used at any point of time in the series. There are certain conditions. The condition number 1, series should be perpetual. This model is not applicable for annuity or a single cash flow series. Series should be infinite series. Second, cash flow should be constant time gap, and the discounting rate should be constant. If all these 4 conditions are satisfied, only then this model can be applied. And what is this model? If we write in general term, present value at nth should be equals to CF nth plus 1 upon I. What I can say is, present value will be calculated at the beginning of the period. At the beginning of the period, we have calculated present value at T0. And the cash flows are standing at T1, starting at T1, that is end of the first year. So present value will be calculated at the beginning of the period, from end of which the cash flows become constant. So how to apply this model? This becomes our ultimate model. This model is called as perpetual constant cash flow model. Now, how I am going to apply this model? So, I am going to take some example. Let's say the series is T0, T1, T2 and T3 and T4 and so on onwards. There are no cash flows for 3 years. And then the cash flows will become 100, 100 and 100 so on till infinite. Now, I want to calculate present value at 0. Now, how to calculate it? There are two ways. First, use mathematics. Second, use model directly. So, I am going to do it first with the mathematics. If I want to calculate present value at 0, I have to go backward, that is discounting. So, first 100 is standing at T4. So, it will start with 100 divided by 1.10 power 4, then 100 upon 1.10 power 5 and then infinite. Again, I can take 100 common. I can take 1 upon 1.10 common. Power 3 common, not 4. What will be left in the bracket? It will be 1 upon 1.10 power 1, 1 upon 1.10 power 2 and so on till infinite. And this bracket is same bracket what we have already calculated as 1 upon 0.10. So, it becomes 100 into 1 upon 1.10 power 3 multiplied by 1 upon 0.10. So, it gives you the first and the third term. It gives you 1000 divided by 1 upon 1.10 power 3, that is equals to 1000 divided by 1 upon 1.10 square divided by 1.1 cube. So, it is 751.31. So, earlier it was 1000 because the cash flows were standing at T1. Now, the cash flows are standing at T4. Let's use the model directly. Let's split this series into two parts. First, let's calculate the step 1. We generally call it multi-stage model. We will start series from T3 itself, though we have to calculate PV0. But let's start the series from start of the 4th year, that is T3 and so on. Here the starting cash flow will start from T4 and so on. First calculate present value at T3, PV3 question mark. And if you see, this series is exactly same series what we have already calculated in the model. So, I can say PV3 from T3, if you see from T3 till end, it is an infinite series, condition 1 met. Second, all cash flows are constant after T3. There is a constant time gap and the discounting we are going to do at the rate of 10%. The constant is. So, it means from T4th cash flow, my all 4 conditions are satisfied. So, value can be calculated at the beginning of the period at the end of which the cash flows are satisfying this condition. So, at the end of the 4th period, T4 is representing end of 4th period. So, value will be calculated at the beginning of 4th period, that is T3. T3 represent end of 3rd year and beginning of 4th year. So, we can use the value PV nth is equals to CF nth plus 1 upon I model. That means PV3 is equals to CF4 upon I model, that is equals to 100 divided by 0.10 gives you 1000. What this 1000 means, where it is standing. This 1000 is standing at T3. This 1000 is representing all the 100 which are standing from T4 till T infinite. Now, they are already brought to this point T3 and they have been added. Now, the consolidated value of all the hundreds from T4 till T infinite at T3 is equals to 1000 only. So, now I can replace my original series from T4 to T infinite, all 100 can be replaced. Step 2. Now, the series is very small. It is T0, T1, T2 and T3. I want to calculate PV0. There is no cash flow for T3. But the cash flows from T4 to T infinite already brought to T3 point is relatively equals to 1000. Now, I want a value at T0. Can I calculate it? Yeah, now it becomes a single cash flow. All the hundreds from T4 to T infinite are now standing at T3 and they are representing 1000 rupees. So can I calculate PV0? It is 1000 divided by 1.10, discounting for 3 year, it gives you 751.31. Let's do another illustration. Question number 2. Let's say the series is T1 10 rupees, T2 20 rupees, T3 50 rupees, T4 100 rupees and T5 is 100 rupees. And till infinite it is going to give me 100 rupees. Can we calculate the present value at T0? Again, same method. We can use mathematics, we can use model also. Generally, model will be prescribed for exam purpose. So first let's go for mathematics model. 10 standing at, we have to discount everything, back to T0. 10 standing at T1, one step back, 1.10 power 1. 20, 1.10 square. 50, 1 upon 1.10 cube. No pattern till here. And then 100, 1.10 power 4, 1.10 power 5 till infinite. First cash flow I have to calculate individually. 10 divided by 1.1, 9.10 plus 20 divided by 1.10 square. No, 20 divided by 1.10 square is equals to 16.53 plus 1.10 cube yx3 reciprocal into 50 gives you 37.57 plus. So individually I have calculated the first three extraordinary. When I am saying extraordinary means other than the routine pattern values. Now what I can do, again the same thing, 100 into 1 upon 1.10 power 3 and inside 1.10 power 1, 1 upon 1.10 power 2 till infinite. Again the same bracket, we can replace this. So first three values, let's add them, plus 16.53 plus 9.1 is equals to 63.19 plus 100 into 1 upon 1.10 power 3 multiplied by the 1 upon 0.10, the bracket will convert into 0.10. So it is again 63.1019 plus 1000 divided by 1.10 power 3, that is equals to 63.19 plus 751.31 should be equals to 31, gives you 814.51. This is mathematics. Can we use model directly? Yes. Again, split the series into two parts, extraordinary cash flow separate and ordinary routine patterned cash flow separate. Step 1. From T3 to T infinite. Don't use T3's 50 rupees. Keep it 0. 100, 100, 100 and so on. Can we calculate PV3? Excluding the CF3, the cash flow which is standing at T3. We are excluding that at present. Yes, we can. Again, we have model PV nth is equals to CF nth plus 1 upon I. All four conditions are satisfied here. Since all four conditions are satisfied at T4, that is end of fourth year, the value can be calculated at beginning of fourth year, that is T3. So it is 100 divided by 0.10, that is equals to 1000. This 1000 is standing at T. This 1000 is standing at T. PV3 is equals to this. So this 1000 is standing at T3, which represent all the 100 rupees from T4 till T infinite. Step 2. Now calculate. Now the series is small, not till infinite. We want to calculate PV0 question mark. T1, T2 and T3. 10, 20, 50, because 50 is not included in 1000, which is standing at T3, plus the 1000 is also now standing at T3 because all 100 now brought back to this point T3 is representing that 1000. So now can we calculate PV0? Yes. 10 divided by 1.10 power 1, 20 divided by 1.10 power 2 and 50 divided by 1.10 power 3 and 1000 divided by 1.10 power 3, not 4. Same series. Again, it is equals to 814.51. So this mathematics, multi-stage mathematics, we will be using for valuation of different type of instruments in the next sessions. Next model, perpetual constant growth model. Now the cash flows are growing by 6%. This 6% can be calculated with a certain model, but now let's assume that growth rate is 6% in the cash flows. That means your CF nth plus 1 is equals to CF nth 1 plus growth. Every second cash flow, every consecutive cash flow is growing by a constant rate. That is why this model is called as perpetual constant cash flow growth model, growth cash flow model. Again, we want to calculate present value. Again, discounting 100 standing at T1, one step back, 1.10 power 1 in denominator. 106 standing at T2, 1.10 power 2 in the denominator. 112.36 standing at T3, 1.10 in the denominator with power 3 and so on. Can we take anything common from the numerator? Yes, we can take 100 common from the numerator. So if I take 100, that is your CF1, 100 is also CF1. If I take 100 common from the numerator becomes, first term becomes 1 upon 1.10 power 1. In the second term, it is 106 and we are taking 100 out. So it's not 6, it will become 1.06 because multiplicative property will work. So 1.06 upon 1.10 power square. We are not taking anything common from denominator because I have to arrive at a model. So now again, if we see this bracket is again becoming a geometric progression, infinite geometric progression. Same rule, same formula, sum of infinite GP is A upon 1 minus R. Now in this particular case, this is your A. 1 upon 1.10, yes. And what is G? G is second term divided by first term, the rate of change in this GP. So it is 1.06 upon 1.10 power square whole divided by 1 upon 1.10, it will leave you with 1.06 upon 1.10. Now putting the values, taking LCM in the denominator, cancelling out 1.10, we got 1 upon 0.04. What is this 0.04? This is only the difference between your discounting rate and the growth rate. This is nothing but else 1 upon 0.10 less 0.06, which is your I and which is your growth. Putting this value in the bracket, we got 100 as it is, we got for bracket, we are going to replace it by 0.04. It becomes 2500. 100 divided by 0.04 is 2500. So the same series, 100, if the cash flows are constant, 100, 100, 100, the present value is 1000. Now if the cash flows are increasing by 6%, the value, present value, relative present value will become 2500. Of course, the nominal value will be infinite because when you are going to add all these value in nominal term, of course still infinite values will become infinite. But relatively they are only equals to 2500. Why this is so small value? Because as the cash flows move forward on the time series, their relative present value for T0, they decreases. The first become 90, second became 82, 75 and so on. Gradual decrease is there. So what is the model we are using? So if we see this 100 was CF1 and this 0.04 is representing nothing but else the difference between your discounting rate and your growth rate, that is 0.10 and 0.06. So it is CF upon 1 I minus Z. But this model cannot be used at any place. There are conditions. There are 5 conditions now. First, I should be greater than G, otherwise denominator will become negative. Present value of positive values cannot be negative. So condition should be that I should be greater than G. Second, it should be an infinite series. Third, cash flows should not be constant. The growth rate should be constant. Time gap should be constant. Discounting rate should be constant. We can say that the cash flow which will satisfy all these 5 conditions The point at which all these 5 conditions will be satisfied. The end of the year at which all these conditions will be satisfied. Present value will be calculated at the beginning of the period. So cash flows are satisfying condition at T1, that is end of year 1. The value got calculated at beginning of year 1, that is T0. So in general the model becomes PV nth is equals to CF nth plus 1 whole upon I minus G. So how to apply this model? How to apply this model? This model we are going to apply, let's say, same example. Let's discuss the same type of example. Question number 3. T0, T1, T2, T3, T4, T5 and so on. Let's say here the growth rate is, let's say, 4% only. And I is your 10% again. The first year cash flow is dash, second year cash flow is dash, and now it is 50. The second will become 50 into 1.04, that is 52. Third will become 1.04 multiply, it is 54.08 and so on. This is right now assumed. Means it will be given in the question. Or if cash flows are given, then you can calculate G other way around. 52 minus 50 upon 50, that is also your way of calculation of G. Now I want PV0. There are two ways. Use mathematics. PV0 is equals to 50 upon. It's standing at T3. We want to bring it to T0. 1.10 power 3. 52. 1.10 power 4. 54.08. 1.10 power 5 and so on till infinite. Let's take common 1 upon 1.10 power 2 and 50 common. Inside it is 1 upon 1.101, 1.04 upon 1.10 square, 1.04 square, 1.10 cube, so on till infinite. Can we take the sum? Yes. The sum is equals to 1 upon 1.10 square into 50 into 1 upon 0.10 minus 0.04 in this case. The same A upon 1 minus R we will be using for this and we will arrive at this. This is equals to 50 divided by 0.06 divided by 1.10 square gives you 688.71. There is a second way, alternate way. Go for two-stage model. Step 1. Break the series into two parts. Start series from the point where the cash flows are meeting the condition, that is T2 with dash, because this is starting of third year. From third year end the conditions are satisfied. 50, 52, 54.08 and can we calculate value at PV2? Yes, we can, because I is greater than G, constant growth cash flow, constant discounting rate, constant time gap and infinite series. All 5 conditions are satisfied at the end of third year. So value will be calculated at beginning of the third year. We can use PV nth is equals to CF nth plus 1 upon I minus G, as PV2 is equals to CF3 I minus G. This gives you 50 divided by 0.10 minus 0.04 is equals to 833.33. What does 833.33 represent? This 833.33 represents relative value at T2 for all 50 and increasing value by 4%. From T3 till infinite, what is the consolidated relative value at T2? So we can replace the complete entire series from 50 till infinite with this 833 on T2. Now this becomes your step 2. Step 2. Now we have limited series T2 till T2. We want PV0. No cash flow, but 833.33 is standing here. Just bring it back for 2 steps. We got PV0 is equals to 833.33 divided by 1.10 power square, it is again equals to 688.71, the same value. So any of the way we can use. Again, we can put the second same type of example, that 10 plus 20 plus 30 and so on, and then 50-50 increasing. So I hope everyone understood this. So let's go for the next part, unequal cash flows, but limited series. Unequal cash flows and unlimited series, you cannot calculate present value or future value. But for limited series, can you calculate present value and future value? Yes. In simple calculator, you have to calculate value of each and individual value. But here, in financial calculator, there is a symbol CF, second row, second symbol. Right now, I am having some values. How I found out that there are certain values? I press CF, I got CF0 as 0, and then I press the down arrow key in the top row. There is 100 placed here. It means there is some value already stored in this calculator. How to clear these values? Press second again and press clear. Now your cash flows stored in calculator are already deleted. There are no cash flow. Press down arrow key. The CF0 is also 0 again. Go back to up arrow key, will again go back, and down arrow key will go move forward. So right now the CF are 0. All cash flows are 0. Now I have 100, 200, 280 standing at different point of time. It's a limited series, and now I want to calculate present value. Present value means discounting. Discounting means 100 placed at T0, so step 1 back, so 1.10 power 1, 200 step is at T2, so 1.10 power square, and 3 and then 4. In simple calculator, you have to calculate each and individual value. It's better to make a format if you are using simple calculator. This type of table will make your work easier, because right now there are only 4 cash flow. If there are 10 cash flow, it is very difficult to write in the equation format. It's easy to write in the table format, and less error will be there. So what I have done, year 1, 2, 3, then cash flows, and then the PV factor. Now what is PV factor? I have calculated this 1 upon 1.10 power 1, 2, 3 and 4 in a single calculation. How? Divide by 1.10, you will get power 1, you will get power 2, you will get equals to power 3 and power 4. Place these values. Now these are already values calculated after dividing by 1.10 with a respective power. Multiply these values, because these division will be multiplied. Multiply, you will get 100 is equals to 90 rupees. 200 is relatively equals to 165 at T0, present value 0. So consolidated is 461. So if there are 20 values, you have to make a table of 20 values. In this financial calculator, it's easy. First of all, it should be in the E&D mode. C0, there is no cash flow. Go for a down arrow key. Go for a down arrow key. The first cash flow is what? 100. Now C01 is right now 100. Press 100 and then press set, the second key on the top. Now 100 is placed at T1 in this particular calculator. Press down arrow key, it will give frequency. F represent frequency. How many times 100 is appearing consecutively in this series? Consecutively. Only once, so 1. Nothing to enter. It is by default, it will come 1. Again down arrow key, C02. What is the second cash flow in this series? It's not cash flow standing at T2. What is the second type of cash flow? The second cash flow is 200. 200 set. You have to press set. Now 200 is set as the second cash flow, but how many times it is appearing? Frequency by default. Press down arrow key, you will get F02 as 1. The second cash flow's frequency. It says it's coming 1 time. No, we have 2 times. Press 2, set. What calculator will understand that 100 came for first 1 time, so it is placed at T1. 200 is coming for 2 times, starting with T2. Then it is 200 at T2 and 200 at T3 also. Down arrow key, C03 is 0. It does not mean that cash flow at third T3 is 0. It is third type of cash flow. The third type of cash flow is 80. 80 set. Down arrow key, F03 is by default 0. Nothing to put further. Automatically C04 onwards, it's 0. Now press NPV, the third key in the second row, you got I, the discounting rate. Press 10, set. 10 and then set. Press down arrow key, it gives you NPV, net present value. What is the plus after considering all plus minus? Right now I am having only plus values. You can put even negative values here also. We will be doing it for capital budgeting where there will be some investment and then there will be certain inflows. What is the net present value after considering all inflows and outflows? Press down arrow key, it will give you NPV at present 0 and then press CPT. You got 461, the same value from the table what we have arrived, 461. Can you calculate future value? I have already got these value. Again press down arrow key. It says NFV, net future value. Again press CPT, compute. Your net future value of this series is equals to 675. What this 675? I have given this 675 here. What this 675 means? Which series is beneficial for you? Think upon this. I have to pay 100, 200 and 280 here. I am saying let's settle it today for 425.09. 429, na? 461, sorry. 461.01. I am saying I do not have money for next 2-3 years. I will settle at the lump sum at the T4 for 675.10. By opting which series, borrower or the lender, recipient or the payment person doing payment, which one is who is going to have higher benefit? No one. Relatively, these series 1, 2, 3 all are relatively equal. Only thing is cash flows are placed at different point of time. How to calculate future value? Of course, you have to move forward, that is compounding. So first 100 is standing at T1. You are moving to T4, only 3 steps forward. Then 100, 200 standing at T2, 2 steps forward, 1 step forward, and the 80 step itself is standing at T4. You need not to move forward power 0. Anything power 0 is 1. You cannot take anything common out of the series. You have to calculate each and individual value and then add it in the simple calculator and it will give you this. In financial calculator, you can put cash flows, 20 cash flows, you can put 20 cash flows and then directly calculate with the CPT function, NPV and future value. So I hope everyone understood these concept of perpetual constant series, perpetual constant cash flow series, perpetual constant growth series and unequal cash flow limited series present value and future value calculation. These will be required in our capital budgeting and valuation topics. So do practice for these type of questions. We have questions in our question bank also. So please do the practice. Thank you so much.